Hello everyone, welcome back to the channel. This is Mohit Gowda, pursuing my education in Sri Venkateshwara College of Engineering, bearing the USN 1VE21 CS 101. So, today we are going to learn about binomial distribution. In probability theory and statistics, the probability distribution with parameters n and p is the discrete probability distribution of the number of successive in a sequence of n independent experiments, each asking yes or no questions and each with its own Boolean valued outcome. In the world of binomial distribution, discover the fascinating word of binomial distribution, where probability meets reality. Learn about the mean and standard deviation and how they can help us understand the world around us. So, the introduction to binomial distribution. What is binomial distribution? Binomial distribution is a probability distribution representing the number of successive in a fixed number of trials. So it is used when and where it is used. It is used when there are two possible outcomes for each trial and the trials are independent. Why binomial distribution is important? Binomial distribution helps us model and predict real-world events with accuracy, from flipping coins to evaluating business successive rates. So now we are going to learn about the definition of mean and standard deviation in binomial distribution. First, mean, represented as mu. The mean of binomial distribution is the average number of successes in a fixed number of trials. The standard deviation is the binomial distribution in which it measures a spread of the distribution. Variance. Variance is the square of standard deviation in which the degree to the individual data points is spread out. So now we are going to see the formula for binomial distribution. As you can see on the screen, p of x is equals to n by x, p to the power x, q to the power n minus x, in which p is the binomial probability and x is equals to number of times for a specific outcome within n trials. N by x is the number of combinations of the binomial distribution. P is the probability of success on a single trial. Q is the probability of failure on a single trial. N is equals to the total number of trials in the binomial distribution. So now we are going to see how to calculate the mean and standard deviation of binomial distribution. As you can see, there are four different steps. Step 1. We have to determine the number of trials, that is n, and the success probability p. Step 2. Calculate the mean mu by multiplying n by the success probability. Mu is equals to n into p. Step 3. Calculate the variance sigma square by multiplying n by the success probability and failure probability. Sigma square is equals to n into p into bracket 1 minus p. Step 4. Calculate the standard deviation sigma by taking the square root of the variance. As we know, variance sigma is equals to square root sigma square is the standard deviation of binomial distribution. So here are some of the examples of binomial distribution. Let's get going. Example number 1. Flipping a fair coin. The experiment is a fair coin is flipped 50 times and record the number of heads. The mean and standard deviation of this is calculated. The mean is mu is equals to n into p. As we know, the number of flips a fair coin is flipped in this is equals to 50. So n is equals to 50 and p is the probability of getting heads, that is 0.5. So the mean is 25. The variance is sigma square is equals to n into p into 1 minus p. So the value of n is 50 and the probability of getting edge is 0.5 and p 1 minus 0.5. So the variance is 12.5. Then we calculate the standard deviation, which is sigma is equals to square root of sigma square, that is the square root of variance. So we get the value of standard deviation as 3.54. So here is the second example. Rolling a dice multiple times. The experiment is to roll a dice 100 times and record the number of sixes in successes. The mean and standard deviation. The mean is mu is equals to n into p. As we know, the dice is rolled 100 times and the probability of getting 6 is 1 by 6. So after calculating, we get the mean as 16.67. The variance is sigma square is equals to n into p into 1 minus p. So the value we get of the variance is 13.89. Then the square root of variance gives the value of the standard deviation. So the standard deviation is 3.74. So here is another example. Example number 3. Success rate of a marketing campaign. Number 1. The scenario. A marketing company is running a campaign targeting 5,000 people with a predicted range rate of 4%. Success rate is given as 4%. So the mean and standard deviation of this has to be calculated. The mean is mu is equals to n into p, where the targeting people is 5,000. So n is equals to 5,000 and the probability of success rate is 4%. So we get the mean as 200. The variance is uh, sigma square is equals to n into p into 1 minus p. After calculating all this, we get 192. The variance is 192. Then the standard deviation is calculated. Sigma is equals to square root sigma square. That is, we get the value as 13.85. So the conclusion, what we have learned and the importance of understanding mean and standard deviation of binomial distribution. So what are the applications in real life of binomial distribution? Understanding the mean and standard deviation can help us predict the outcomes, evaluate risk which comes, and make informed decisions in our life. The business benefits which are taken from the binomial distribution. Business can use binomial distribution to understand success rates of marketing campaigns and predict sales outcomes. The mathematical significance. Mean and standard deviation help us describe the distribution of data and define the parameters of a probability distribution. So that's it for this video. Until next time, see you all.